As a modern security leader, you can no longer afford to think of development, security, and operations as separate functions. In today's cloud-native world, you must champion a DevSecOps culture, where security is embedded into every step of the development lifecycle, not tacked on at the end. It's about making security automatic, continuous, and seamless across your toolchains and CI/CD pipelines. In this lecture, you'll explore what DevSecOps really means, how toolchains are built, and how security must integrate into continuous integration, CI, and continuous deployment, CD workflows, without slowing innovation. DevSecOps is not a tool. It's a shift in how your teams think and work. It's about moving security left, embedding it into development activities, instead of treating it as a checkpoint after the fact. As a leader, you must foster collaboration between developers, security engineers, and operations teams, creating a shared responsibility model where security is everyone's job, not just the security teams. By embedding security early, you catch vulnerabilities at the lowest cost and prevent insecure applications from reaching production. You also change the mindset. Security is no longer viewed as a barrier, but as an enabler that moves with the speed of development. When you are leading a DevSecOps initiative, your success depends on assembling a toolchain that automates, secures, and monitors every stage of the development and deployment lifecycle. But it's not enough to just adopt tools. You must integrate them into a cohesive, seamless flow. Let's walk through the key components you need to focus on and how each one strengthens your security posture without slowing down your teams. First, you must start with source control and versioning. Platforms like GitHub or Azure repos allow your developers to manage, track, and collaborate on code changes securely. But beyond simple version control, you should enforce security standards, such as branch protections, required reviews, and code scanning integrations. Your source control repository becomes the single source of truth, and by embedding security at this level, you create a secure foundation for all future stages. Next, you integrate continuous integration, CI, tools like GitHub Actions, Azure Pipelines, or Jenkins. These tools automate building and testing code every time a change is committed. As a security leader, you need CI pipelines to include automated security scans at every build. Your goal is to detect security vulnerabilities as soon as code is written, not after it's deployed, allowing developers to fix issues quickly while they're still close to the code. A crucial part of early detection is static application security testing. SaaS tools scan source code during the development phase, looking for vulnerabilities like insecure coding patterns, injection flaws, or hard-coded secrets. By integrating SAST into your CI workflows, you ensure that security risks are identified long before they ever reach production. Your developers get rapid feedback, and your teams build a culture where writing secure code becomes second nature. In parallel, you must deploy software composition analysis. Modern applications rely heavily on open-source libraries and third-party components, and many breaches start with a vulnerable dependency. SCA tools scan your application dependencies, detect known vulnerabilities, CVEs, and flag license compliance issues. By embedding SDA early, you prevent your teams from unknowingly introducing risk through external libraries. To protect credentials and sensitive data, you must enforce secrets management. Tools like Azure Key Vault or HashiCorp Vault ensure that secrets, API keys, certificates, and encryption keys are never hard-coded or stored insecurely. You should mandate that all secrets are managed centrally, rotated regularly, and integrated with your applications securely at runtime, not baked into your codebase. As you approach deployment stages, you need dynamic application security testing. Unlike SAST, DAST tests running applications for vulnerabilities like authentication issues, misconfigurations, and injection flaws. You integrate DAST scanning into staging and pre-production environments, ensuring that your apps are tested from an attacker's perspective before they go live. Your infrastructure must be secured too, not just your applications. That's where infrastructure as code security comes in. Cloud environments today are built using templates, whether that's ARM, Bicep, or Terraform. If those templates are misconfigured, you're building risk into your environment by default. Tools that scan IAC templates for security misconfigurations ensure that every resource you deploy, networks, VMs, storage, is aligned with your security baselines before it's provisioned. Finally, you must extend security into the runtime environment through runtime protection and monitoring. When your applications run inside containers or serverless platforms, you need security tools that monitor process behavior, network traffic, and configuration drift. Cloud-native security platforms, like Microsoft Defender for containers, provide continuous monitoring, helping you detect suspicious behavior like container escapes, lateral movement, or unexpected outbound traffic. As a leader, your responsibility is to weave these components together so that they don't act as isolated checkpoints, but as an integrated automated security fabric around your software development lifecycle. The faster you make security feedback flow back to developers and the tighter your monitoring of runtime environments, the more resilient and agile your DevSecOps program will be. When you are leading modern software delivery, you need to see the CICD pipeline as the true heartbeat of your organization's innovation. This is where your teams integrate code, run automated tests, build artifacts, and deploy applications at high velocity. Your responsibility is to embed security directly into this pipeline in a way that strengthens protection without ever slowing down the pace of development. During the continuous integration phase, you must ensure that every pull request automatically triggers security checks. That means running SAST scans on source code, performing dependency analysis to catch vulnerabilities in third-party libraries, enforcing secrets detection to prevent credential exposure, and conducting compliance verification to maintain governance. It is critical that developers receive immediate feedback while their changes are still fresh in their minds, enabling them to correct issues quickly and efficiently. As you move into the continuous deployment phase, your job is to automate security at the infrastructure and application levels. You must set up pipelines where DAST scans are performed against staged applications to catch runtime vulnerabilities, where infrastructure as code templates are validated to ensure secure configurations, and where compliance gates automatically stop unsafe deployments before they ever reach production. When you design security to be an automated, continuous part of the CI/CD pipeline, you create an environment where vulnerabilities are caught early, corrections happen naturally, and deployment approvals are based on policy-driven trust, not manual intervention. Security becomes woven into the rhythm of development, allowing your teams to move fast and stay secure without compromise. The true success of DevSecOps depends on making security invisible but powerful. Your goal is not to burden developers with endless manual checks. Your goal is to build security into the systems they already use: code repositories, CI pipelines, deployment workflows, so that security happens automatically. You must also lead culturally. Developers need to see security feedback as part of their quality checks, not as additional work. Operations teams must see security controls as part of their deployment templates, not manual approval chains. By leading with automation and empathy, you make security a partner to innovation, not a roadblock. So, what's your leadership takeaway? DevSecOps is not just a best practice, It is a leadership priority. When you integrate security into Toolchains and CICD pipelines, you are not just protecting your software, you are enabling your teams to move faster, build better, and innovate securely. Your challenge is to lead this shift, combining automation, collaboration, and continuous improvement so that security becomes a natural, seamless part of how your organization builds the future.